Hello everyone and welcome to the episode 28 of the Mobile Networks Overview course. In the previous episode, I just introduced 5G and some fundamental concepts. In this episode, I wanna go through some more details, but again introductory and not very deep, but just an overview and introduction for the beginners. I have introduced the three slices, main slices of the 5G EMBB, MMTC, and URLLC in the previous episode and some of their applications. According to the frequency which are used in the countries, the slice and the use of that slice can be more significant. For example, for the frequencies more than 6 gigahertz, so the bandwidth can be very wide. For example, here 800 megahertz assignments, which is very wide. So this is super data layer addressing specific use cases for EMBB because the band is very high. The bandwidth is very high, so it is appropriate for some applications that needs a high bandwidth. But in some countries that choose the middle band between 2 and 6 gigahertz, it's a medium frequencies coverage and capacity layer. In a medium range, it can support all of the slices, wide area but no deep coverage. But below 2 gigahertz, all these can support it, but you can see that the bandwidth is low. So some of the features, for example, especially in MBB, EMBB, cannot be fully covered like the others. Okay, this is the from 3GPP reference. This is the main architecture of 5G system. You can see here we have UE, we have an access network here, as you can see, and you can see that we don't have R here, radio access network. It is access network because it can also be fixed. Okay, you can see here fixed Wi-Fi and because of this, in this generation, and I think maybe in the later generations, the standard engineers and researchers have removed the R in the beginning of access network, which means radio. And here you can see it is cloud native and control plane, user plane separated. You can see here is a control plane and here is user plane. We have a control plane here and user plane here. Okay, this is CU cloud native CUPS, control plane and user plane separation. We can see we have some of the network elements here. In this episode, very briefly they are introduced, and since these episodes are not very deeply the purpose of these episodes is not deeply going through the discussions, so just introduction and overview. I will take a look at each of them. This is the first one, is AMF, access and mobility function. You know, in any of the mobile networks there should be a network element for managing the mobility, and also so for example, you remember from the previous episodes, the primary episodes, in the CS we had MSC for mobility management. In the PS and EPC we have MME, but here we have AMF, and also in the next generations there should be an entity, because the mobile network, it names shows that there should be some element for the managing the mobility. And this is session management function, policy, charging function, access function. This is network slicing service function. And we can see that HSS functions are divided into two groups: authentication service function and user data management. Okay, as you can see, all of them can be categorized in control plane. And this is user plane. We have some user plane functions, UPF. And if we want to make a comparison, maybe we can say that, for example, in 4G in PC, it's like the P gateway, PGW. And this is also in the comparison, it can be like S gateway or SGW. We can see that UPF, according to the application of that scenario, can be near to the edge of the network or be far. It depends on the application. For example, I want to ask you a question. If the application and the slice, as the selected slice is URLLC, the UAPF should be close or far from the edge. So what's your answer? You can pause the video. Yes, it should be close, as much as possible close to the access network. So this is, and also we have some data network. When we say data network, it can also be some local data networks or some other networks, and also internet. It depends on the scenario and the network. Okay, here are two, according to 3GPP, here are two main strategy for migrating to 5G. The first one, I think most of the operators go through the first one. At first is non-standalone. You can see they have their own EPC. LTE eNode Bs are already connected, but they also start integrating GNode Bs, GNB, which are the radio access for 5G. But after a while, they can move and migrate to a standalone. SA, NSA, and SA. You can see that here EPC is offloaded and LTE Node B and GNB are integrated and connected to next generation core network or 5GC. Okay, this is the second strategy, and the next strategy, most of the operators after a while go to this. Okay, you can see that the NGC or 5GC is managing both of the radio generations, both 4G and 5G. And they also say there is a technical term that in this, because many of the high bandwidth frequencies are used in the 5G, especially for EMBB, as you saw in the previous slides. The technical term is millimeter wave band. Here we have, and you can see there should be lots of small cell in this area because the coverage is low, because the band is high. And if you ask why millimeter, why the name is millimeter, you can remember that nu is C on lambda. If we can see lambda can be C on nu, and as we know C is 310 to the 8 on nu. If you calculate and put a frequency in this range here, you will see that lambda would be in the order of millimeter, and because of this we tell these millimeter waves. But there is an issue that water vapor absorption band is here, which should be considered in the coverage. Okay, and here is some example for 5G spectrum and the strategies of many regions in the world. For example, in Europe, in other countries, you can see that some of countries just focused on the middle bandwidth, you can see, but some others also in the high bandwidth for some specific EMBB purposes. Again, we can see that for different slices we have different strategies, especially for the UPF. It's based on the scenario, the UPF and the data center. As you can see, the example that I told to you in URLC slicing, you see that the data center and data network is very close, should be very close to the access network. As you can see also here in URLC, you see there should be some local data center, which I think would be a very good business in the future, for example, because just national data center and regional data center are not enough. And in the future, some local data centers, because of meeting the low latency, should be there. And I think many companies can have contribution, and it would be good business. And here we can see that, for example, for some other applications like voice and MMTC, which the latency is not such important as this, so it can be far from the data center. Also, there are some good subjects also in the research fields for who are interested. There are some AIML, artificial intelligence machine learning algorithm, that are used in the in radio, also core part, to choose the best combination of these slices for a specific purpose. As you can see here, we can see that 5G in the near future can handle a smart city. As you can see here, many of the things can be done and managed by the 5G network, such as water quality measurement, smart wearables, utility management, and many other things, health. Let's introduce some of the interesting 5G use cases. You know that AR and VR are becoming very popular these days. So what is AR and what is VR? AR is augmented reality. It means that you wear a glass, you see the realities, but some other things are augmented. VR is virtual reality. It means that you wear a glass and all the things are virtual. We also have some other combinations like XR and so on. And we have here according to frequencies, we have many applications. For example, when we had 1 meg just image and workflow downloading, when 2 meg video conferencing introduced, for 2 to 20 megabit 3D model and data visualization, and so on. We can see, based on the bandwidth increment, many other applications are introduced. You can see AR and VR are very interesting, have very interesting applications. For example, here we see the children. There are some augmented elements in the environment and they are enjoying the game. And here is a young man that looks to a historical building, and some augmented information can be seen, which is really interesting. Also for family communicating, for example, in such bad days like COVID-19 and so on, family communicating would be very easy and nice. And many other things like fitness and so on. This is an interesting thing that it is 60 OF, means 6 degree of freedom. For example, this person here feels that he is in the stadium, and if you can see, if all of these persons were in this stadium, many, it needs huge capacity for upload, and but right now we can see each person is in home or in the workplace and can see and have the uh, exciting area with this technology. Okay. Also, we have AI. You can see we have artificial intelligence and machine learning anywhere in any field. Also, like this in the 5G for automation, automated management of network, and also some other things that I told to you for optimizing the slices and so on. There are also some other use cases for 5G, which is V2X vehicle to everything, and also connected cars. We can see V2I vehicle to in the V2V vehicle to vehicle, vehicle to device, vehicle to the pedestrian, and vehicle to home, and vehicle to infrastructure. 5G plays a crucial and important role in the health. You can see by 2030 there can be $94 billion saving, annual cost saving in the health, with the help of remote patient monitoring. As you can see, has a huge and high portion. We have virtual consultancies, virtual HD consultancies, and some other applications and connected ambulances. Okay, this is a very huge impact. Also, this is some other things that we can see: HD virtual consultation, many things, augmented reality in the also in the training and university applications, the medical science. These are also some other use cases in the health. You can see, for example, neurosurgery can be taught via virtual reality, which is really interesting. So, in the brief, we can say that 5G technology ecosystem consists of mobile network operators, hyperscalers, which I think the most important thing is that they change the game, they scale the market, they bring new things. I think their role is really important in this market. Equipment manufacturers also very important. For example, the device vendors. You can see here system integrators and also software vendors. This is the 5G technology ecosystem, and you can see that it is very wide in comparison to the previous generations. And you can see that there are many things that there are many industries you can see that can be involved: manufacturing, consumer application, retail, construction, transportation, banking, healthcare, many of things. And 5G market industry in 22 to 2035 $1 billion. You can see these amounts are in $1 billion, US billion dollars, which you can see here. The most of them is manufacturing, consumer application, public store, construction, and so on. For example, in healthcare there is $447 billion. And also this 5G private network market size, which is increasing, which forecasted to be increased in the next years. And these are the technology trends leveraged by 5G. You can see there are some trends in this new technologies like Open RAN sharing, massive MIMO, edge computing, which is really important because as long as we go, the computations should be localized because of needing low level of latency, and this is really important. Also, automation and network slicing and private 5G networks. Okay, I want to show you some other slides about 5G core part before finishing this. before finishing this episode. These are important. You can see we have 5G access network and 5G-C, as I introduced before. This is 5G-C, you can see, and 5G-C according to 3GPP is like this. The interfaces and network elements, you can see all of them, all of the interfaces you can see are started by N. Sometimes I think or I tell to the audience that it maybe refer as new, but you can see all of them according to 3GPP. No need to memorize. When you work, it will easily be memorized by you. For example, let's look at the first three interfaces. For example, between UE and AMF there is N1. Between RAN, or you can see here, access network to AMF, this is N2. And also between access network and user plane function, this is N3. Some network elements have a interface to itself, for example like this, which is N9. Okay, and the next thing we can see here, this is the part. This part is control plane function, which I introduced to you before. And the most important thing here, that the protocol stack in the solution-based architecture in this control plane is mostly like this: L2, L1, L2, IP, TCP, TLS, HTTP, and application over that. Many of these, so if you see the previous generations, there was lots of interface and protocols with different protocol stacks. But right now, if you see the trend, the technology goes to the simplified network architecture and also protocol stacks. So protocol stacks in the future, also in the 5G, are unified and more simple. And also they for example in 5G, many of them are using REST API, which could be really nice and interesting for developers. They can contribute in this market and have their own businesses and and help to have contribution and development of better applications and better standards and so on. Okay, I should tell you that from today I will start some new chapters and episodes totally different with this thing on neural networks and artificial intelligence, which is my main passion, in some other chapters. You can follow them. I will start by Python and the simple Python, okay? Because I believe that the future is the ecosystem of future in technology is changing, and we should and maybe one day telecom infrastructures is enough for us, and not more growth, and we should focus on the new skills and the new adventures and also new innovations and many other things. Okay, so because of this I will start the new trainings and new chapters and new contents, which I hope that would be very useful and also informative for you. Okay, thanks for your time. I hope this would be informative and useful for you. Thanks for watching, and hope see you again. Bye.